How to create a 3D NFT collection with React 3 Fiber and publish it on the blockchain. Hi, in this complete tutorial we are going to see how to create a 3D NFT collection using React 3 Fiber. We'll start by creating and displaying our scene and save it into a picture. Then we will add traits and rarity to generate unique images to create our collection. We will upload all those pictures and their corresponding attributes into IPFS using Pinata. Once our collection is ready, we will create and deploy a Solidity contract to mint our ERC-721 NFT collection into the blockchain. If everything goes well, our whole collection will be available on OpenSea. As always, the source code and the 3D model will be available in the description below. Are you ready? Let's go! 3D scene. Let's start by creating our project. So open a folder, yarn create Vite dot. We'll select React JavaScript. The first thing to do is to rename our title here to NFT collection generator, save, and let's add our libraries. So yarn add, we will need 3, React 3/Fiber, and React 3 Drei. Once it's loading the packages, let's go to the source, remove everything to root. We will add a width of 1024 pixels and same for the height. Usually we take the whole screen, but here we want to generate images that are this corresponding size. Maybe adjust it if you want bigger or smaller images. And on the body, we'll add a background color to black to know exactly where our scene is. Okay, now let's go to our app. We will remove everything. Let's create our canvas from React 3 Fiber where we will put our experience, but we didn't create it. So let's create a component folder to organize a bit, even if I won't organize everything. So new file experience.jsx, export const experience, and let's return a basic 3D scene. So we'll add a mesh with box buffer geometry just to display a cube and mesh normal material. So we'll see it, and let's add orbit control so we can rotate a bit. Okay, and here inside our canvas, we'll add the experience we just created. Yarn dev, and let's open it. Okay, so here we have our cube, but we have everything black because our 3D scene doesn't have a background. So let's add one and let's center the content. So here, margin 0, auto to center it. And to add a background color, let's add color, attach background, and let's add the color, which will be a light black. So I will revert, I will put the background color in white and the scene in black. It will be less strange. And here, let's close it. Okay, what do we have so far? So we have our page, and inside we have a 3D scene, which is black, and a cube inside. Now let's load our model. So inside public, create a folder, name it models, and drag and drop our 3D model. Once it's done, let's generate our component from the GLTF file. So let's call gltf.jsx public models and pirate. Okay, it's a library that will generate a JS file from the GLTF file. So we have a component we can work with. So here it is, the automatically generated one. Let's copy and create our component. Let's name it pirate.jsx. We have some fine tune to do. I name my component with pirate, and the path is wrong. It's models. And here there is a preload, so we need to do the same here. And perfect. Inside our experience, instead of the cube, we will add the pirate. Okay. So we see it is here, but the light is in existence. So let's add one. So ambient light, intensity 0.4. It won't look good, but at least we can see it. Okay, so now what we want to do is to set a correct lighting and a correct scene with plane behind so we can change the color. So let's do it. Let's center our model with center from R3F Drei. So here it is centered, but we are too far away. So let's adjust our camera position. So in up on the canvas, we'll add camera, position, and define our settings. So we'll put it in front, so 0, 0, and 4 to get closer to it. And let's add a field of view of 45 degrees. So now we are closer to it, and we need to add some proper lighting. So I use something called 3-point lighting. It's something common in video making. So we have a point light on the right with the default color, which is highlighting the face. We have another light with a nice color, which is a spotlight in the opposite direction. And we have another light which comes from behind to illuminate it. Let's save it. And now our model looks more in 3D because there are proper lighting set up. Now let's create our stage. So const stage equal. And here we will use our stage. Okay, so to create our stage, we have a plane, which is the floor. So we rotate it. We set a black color, but with a very transparent color. So the color will come from the wall behind us and it will look a little bit darker on the floor. Then we had a wall behind the character, which takes a color that we will customize later. And we add a little circle in the top right with a yellow color. And it's a bit transparent, so things blend better together. Let's save. And let's look at what we have. So here we have our character, we have the floor, the color is a bit darker than the background, and we have the sun. Here we put orbit control, so you can see where things are positioned, but it looks nice. Now let's define the default pose for our character. So let's go to Pirates, and here we'll use effect. We will make it happen on animation index. But for the moment, we will put it to 0. But when it changes, we will do some action. So inside use animation, we can get all the different action names. So actions from names of animation index dot reset dot play. We don't need fade in because we will take picture and not animated content. And we will return a function that will stop the previous animation. Let's save. And now you can see our model is in a different position. If you want, we can see the different one. I know one is the default. So here we have the Luffy pose. 3 is the sailing pose. And 4 is the zombie one. Let's put it back to 0. And now let's take a screenshot of our scene, which will be the fundamental to later generate a collection. So this is something we already did in a previous tutorial, so it will be quite easy. We'll go to app.jsx, add a button. Let's add the class name generate collection, and on click it will call a method we didn't create yet, but we'll say window.takeScreenshot. We'll make it better later, so don't worry about it. Okay, in our style for the button generate, we'll put the position to fixed, right to 32 pixel, bottom to 32 pixel. And is it somewhere? Yes, it's here. So let's add the inspector so my camera won't be in front of the button. Okay, now let's make it working. So inside our experience, we will create a method to take the screenshot. We can't make it in app because we need to be inside the canvas to be able to take the screenshot. So const screenshot equals to function. First we create a link. Then we'll set an attribute, which is download, and the file name, which for the moment will be canvas.png. Then we add another attribute, which is the link too. And here we need a variable we don't have yet. So we use const.jl equals to u3. We get the state, and from the state we take, we take JL. By the way, I don't want to code this method in stage, but in our experience. So here it's better. So here in the link to href, we'll do jl.dom element, which is in the canvas, .toData URL, and we say image/png, and we will replace image/png to image octet stream. And to start the download, we will do link.click. So let's do something really ugly, which is window.takeScreenshot equals to screenshot. So we can't call it, but later we will change it, so don't worry. So now, if we go here, we go to generate collection, we have a screenshot taken, but it looks black or at least empty. It's because we need to go to setup our canvas. Here on JL, we add option and it's preserve drawing buffer and set it to true. So now if we reload, we generate, well, it's not a collection, it's an image, but we have our model. But be aware, if we move the camera because it's taking a real screenshot, it will take a screenshot of what is displayed. So if you want to avoid to badly manipulate it, maybe remove the orbit control. Now let's generate our unique NFTs. Collection unique traits. Let's start by creating a context. So folder context. And let's create collection generator.jsx. Let's create a default context. So const collection generator context equals to create context. Const collection generator provider equals to, here we have the children, we'll return collection generator context.provider with the value. It will be an empty object for now. Inside we will wrap our children and we will close our context. And we will also create a function which is use collection generator. It will just return use context from our context. Perfect. Don't forget to wrap our application inside the context. So collection generator provider. It doesn't want to autocomplete, so what we can do is go here and maybe export everything. Here, no. Okay. And now I can use it. Perfect. So what do we need in our context? So we want to have a current item we want to display. So it's current item, and this item will contain all the traits our model have to be displayed and to save the picture and the metadata. So set current item. It will be equal to useState because we want it to be saved, at least for every render. And generate item, which is a method we will create. Now let's create our method generate item. And what we will export is our current item. So the item we will generate is an item. It's an object containing the different keys and an object for all traits. So we will return it. And now we will have to put some logic to generate it based on the traits we will define. So before that, what we will do is to define our different traits. So for that, I created an object which is called traits collection. For the moment, we will work only with the background. So it's called traits collection. It has a key, which is the name of the trait. And we have a text value, which will be used to be displayed on OpenSea. We have the value which we will use inside our generator. So it's the color itself. And we have a weight, which will impact how rare it is. So 40 is quite common, but 10 is quite uncommon. You can see that I used a total weight of 100, but you can do whatever you want. You can put 1000 here and nothing on the rest. It's easier to work with percentage. Okay, so now inside our generate item, what we will do is to loop over each attributes. So what we'll do is object.keys from trait collection. For the moment, there is only one, but we will have all the others which will work the same. And for each, we will have the key and write our logic here. So the array of traits is traits collection from key. So here inside key, we will have background and the traits will be this array. We will save the total weight. So it's 0. We loop over traits. So total weight will be incremented by trait.weight. So here we will have 40 plus 30, 70 plus 20, it will be 90, and 10, it will be 100. So that's why I said it's not important the value you set, because we don't use percentage, we use weights. And over our trait, we'll set the combined weight, which will be the current total weight. So I explain what it does. We'll have 40 here, because we are at 40. And here we'll have 70. And here we'll have 90. And we will assign to tropical 90. And on space, we'll assign it 100. I'll explain to you later why we do it. So now we will define the rarity. It will be a number, so use randint from a 3 between 0 and the total weight. So we have a number in our example, between 0 and 100. So if it's below 40, it will directly be the C. If it's between 40 and 70, because it's the combined weight, then it will be the desert. If it's between 70 and 90, it will be the tropical. And if it's above 90, it will be the space. So that's why we use the combined weight to be able to use the interval. So how do we code it? Let selected trait is the first one, so 0. So we loop over it. So let I equal 0, I below traits.length. We increment I. So let trait equal to traits of I. If the rarity is below trait.combine_weight, then we select this trait. So selected trait equal to trait. So I made a mistake here. Selected trait is equal to traits of 0. So we always take the first one. And then we don't want to go to the other one because there are more chances that it happens. So we just use break. That's why we use for and not fancy for each or map. And now item of key is equal to selected trait. So what we will have is inside our item, we'll have the key, so background, will be equal to one of those objects based on the chance you had. Okay, so for now, let's just console log the current item. So we reload and we look at it. We have inside background, we have desert, which is this color with a weight of 30, but we don't mind. If we do it again, we have tropical with a lighter weight. Okay. So now let's change our background based on the value which is here. So we go to our experience. Here is the background. So we will use our hook. So we have current item from use collection generator. Instead of putting our value hard written here, we will use current item dot background dot value. Now we reload. And if we reload, we see we can have a different color based on what we generated. So now we just have to do exactly the same for the other traits. Of course, I prepared it because you don't want to spend hours with me. So what I created, we have the sun. It can be yellow 90% of the time, or it can be red, which is quite rare. We have the bird. It can be brown, usually blonde, white, or red, which is the most unique. The eyes, it's the same, unless it's blue eyes and not blonde eyes. For the shirt, I made 4 color. For the pants, I made 4 color as well. And there is also the animation, the pose. And here, instead of having a color, we have the animation name, which comes from our 3D model. We save it. And we just have to go to our different part and apply it. So we'll start by the stage. So here the sun is always yellow, but we want to see it. So it's not background, it's sun. Here, if we look, it's red, yellow. Usually it will be yellow, but sometimes it will be red. So what else do we have? Then it's all on the model. Okay. So let's go to Pirate, use current item equals to use collection generator, and let's apply the material color. So we have the skin, we didn't play with it. We have the bird. Beard. Okay, so sorry. So skinned mesh. Let's close it. And we'll add a mesh standard material with all the properties we had in the beard one. But we will be able to change the color, and we will use current item dot beard dot value. And here we need to deconstruct it. So let's save. Does it work? It's brown, it's blonde, it's red, it's blonde, it's brown. Perfect. So now we just have to go over all the different ones. So here /skinned mesh materials, we're in the jacket, but I name it shirt. We have the pants. So I name it pants too. we have the eyes. Its eyes too. Perfect. Did I forget something? I don't think so. So let's reload. You see we have the color which is changing, so it's quite nice. By the way, if you want to fine-tune the colors, what you can do is, let's say you want to change the pink, it's not your taste. You can put a very high weight and reload, and there is a high chance, because the weight is enormous, that it will always be pink. So you can use it to fine-tune the colors. Okay, so last thing we didn't set up is the pose. So here, so inside our pirate, instead of setting animation indexed to 0, we will use names.index of, and we'll use current item.pose.value. So it will give me the index of that particular string. We save it. And here it's in this animation. Here is the sailing one. Here it's the zombie. And here is the Luffy. Perfect. So now our rarity logic is working. We just have one thing to do, is to loop over the collection size, maybe 10, maybe 100, maybe 1,000, and take screenshot and save the metadata every time. So how we will do it? Inside collection generator, we will create a new function. We will name it const generate collection equals to, and here we will expose it. The only thing it will do is to change a state. We will name save screenshot and set save screenshot equals to use state of false. What it will do, it will put save screenshot to true. So it will tell the application we want to start taking screenshot of what is happening. We will do a callback. So when an item is created, we will do another one. So expose a new method, which we will call screenshot taken, which will be called by the component which is taking the screenshot. So what we will need is a collection item number, and by default it will be 1, because we don't want to use 0 and add +1 every time. We will also need the collection size, so we will define it outside. Let's work with 10 for the moment. So when a screenshot is taken, if our item number is below the collection size, then we will generate a new item. So set current item to generate item, and set collection item number to collection item number +1. By the way, maybe in the other order. If it's not the case, then we stop taking screenshot and we set the collection item number back to 1. So if we start a new collection, it starts from 1. And here, what we need to do is to make it available inside the context. So let's save it. Inside our experience, we will remove it. We'll make a use effect based on if we save screenshot and the collection item number. So we need them. So save screenshot, collection item number from our hook. So if we know we have to take screenshot, or if the number change, we take a screenshot. So if save screenshot is true, we take a screenshot. Perfect. So now inside our application, instead of calling this horrible thing, we will use generate collection from our hook. So generate collection equal use generate collection generator. By the way, here it's defined, so we can use it like this. So now we reload. If we click on generate collection, nothing is happening. So let's look why nothing is happening. So generate collection is here. Let's log it. Console is not a function, yes. So it's going here. Save screenshot. Oh, it's never exported, so it's not known. So here. Now let's reload and generate it. And you can see we have only one screenshot which was taken. So here, let's write it, collection item number and collection size. Let's reload, let's generate. And screenshot taken isn't called, so I forgot to do it. And it only took one screenshot. So here in our experience, once we have done our screenshot, we can call screenshot taken. So our context, we know it. Now let's go back here. Let's generate. Still not working. So let's see what is happening. So we have 1 and 10. And oh my God, I forgot everything. So here it is, it's available. So it will trigger a change and it will take a new screenshot. So let's reload, generate collection. And here we have all our files. Let's have a look at what we have. We have some images and they are all different and unique. So it works pretty well. But before being able to upload it to OpenSea, what we will do is generate the metadata telling which attributes are. So what we need to do is to look at OpenSea metadata standards. And you have the structure. So we need a description, an image path, which will be IPFS 1. We need the name of our model and the attributes. So the attributes, let's look at what it is. It's the name of the trait, so us, background, pose, shirt, etc. And the value. And us, we named it text value because we want not to display the hexadecimal color, but the name of the color. So, okay, let's generate a JSON file for it. It's quite easy. We have all the data. So let's go to experience and let's create a save metadata. It will be quite the same. So it will be a link. It will be a download. So here it is. The name, by the way, we didn't rename our file here. So first, JSON. So here we want to name it with the current item number. So let's change it. We'll use collection item number.png. Okay. And here we will do the same, but with JSON. Then we will need to create a file. So const file equal to new blob. It takes an array. Inside we need to stringify the metadata. Null and 2, so it will be displayed nicely. And the second parameter is the type of the file, which is text/plain. Now link set attributes href url.create object URL from our file and click on the link. But here, if you have noticed, we didn't create our metadata, so let's do it. So metadata equals to an object. We know we need a name, a description, an image, and the attributes, which is an array. For the name, we will name it pirate number, and we'll use the collection item number. Description is what will be written on OpenSea. So what I did is Wawa Pirates, a collection of 100 unique pirate NFTs. By me, I'm gonna be the king of pirates. The image, which will be IPFS.// You don't have the URI yet, so you need to do something that we will replace later. So I use IPFS_URL / collection number.png. So it will be in 2 steps. We will upload our files, our images, and once we have it, we will be able to update this parameter in the JSON. And for the attributes, we will use current item. Do we have it here? Nope, we didn't need yet. So current item dot map. Well, it's an object. So object.keys.current item. So we have all the keys. We will map it. So we'll have the key, and we'll return an object. So we need trait type, which is the key. It will be background, pose, shirt. And we need the value, but for us, it's current item of key text value. Okay. We save it, and now we have saved metadata. And once we take a screenshot, we also save the metadata. Let's look if it works. So reload, generate collection. Okay, what do we have? We have 1, 1, 2, 2, 3, 4, 5, 6. But the other one didn't come out. And it's a downside of what we are doing. It's because it's not server side, but it's using our browser, and you can have spam protection and stuff like that. We can make it work easily, but it's a downside you have to have in mind. So what we will do is create a function named process screenshot. It will be async, and we will wait before taking the picture. So we'll take a screenshot, and then we will sleep. Let's say 150 milliseconds. We will save the metadata. We will sleep again. And then we will notify, let's go to the next item. Let's define our sleep function. So utils, new file, sleep.js. It's just a promise and a set timeout, but it's better to write it with a wait. And here, what we do is process screenshot. Perfect, let's try again. Let's generate our collection, and sleep is not defined. Okay, let's import it. And now it works way better. We have into the 10 and they are in the correct order, which was not the case before. By the way, we didn't look at our file, but here we have the name, the description, the image, the attributes, and all the traits. You don't have to define the percentage and the rarity. OpenSea will calculate it automatically based on the collection and the items it has. One last thing, our items are not guaranteed to be unique if we generate like 1,000 item collections. But we want it to be, so let's change our collection generator. And we will add a new object. Here, we'll name it generated items DNAs. It will be an empty array. What we will do is every time we generate an item during a collection, we will save all the rarity for each trait and generate a unique string and compare if we already did that object. Then we will regenerate it because it already exists and it's not unique. And what we like about NFTs, it's when it's unique. So here we'll define an item DNA. It will be an empty string. And here item DNA plus equal the rarity. Here what we do is if generated item DNAs includes our new item DNA, then we will regenerate it because it already exists. So return generate item. Beware, it's a recursion. And if there are not enough possibilities, it may loop forever. So be aware of your collection size and the possibilities you made. If it's not the case, we will do into our generated item DNAs, we will add our new DNA. But what we also need not to forget is here to empty our object. So generated item DNAs.length equals to 0. Or we can put it at the beginning. Here, generate collection. Here we empty it. So what we can do is at the end, console.log generated item DNAs. Let's stringify. And let's see what we have. So we generate it. And here we have all the DNA, which are the rarity it got. So 26, 39, 55. So we are sure the key is unique and there won't be collision between models. Publish IPFS. Before publishing, let's generate 100 items collection. Let's go to collection size, define 100. I cleaned a bit my download folder and generate collection. We wait just a few seconds that the 100 are processed. Okay. So once it's done, I go to downloads. I take everything. I create a collection folder. And I drag and drop everything here. It displays 200 files, which seems correct, so perfect. If your download folder wasn't clean, be sure that the names are correct and there is no parenthesis 1 or duplicates. Okay, now we have collection and its version, so go to the git ignore and add the collection folder. Now go to package.json. I prepared two scripts. So the first one, what it does, it's creating a metadata folder and an image folder and move all the images into one and the JSON into the other one. Basic command line. Use yarn prepare. And inside collection, now it's separated your images and metadata. So now let's go to Pinata. What it does is it will post our images into IPFS, but it will pin it, which means the file won't be ever deleted and be available always by Pinata. So you need to create an account. Here you can see I already have files existing. So upload, folder, and here select the images folder. We will start by uploading the images. So upload. Here I just deleted my pins because there's a limit, which is 100 files. So my collection is too big because we'll have both the image and JSON. So we will build again the collection with 50 files. So let's change it, collection size 50. Don't forget to go to experience and change the description if you say like me that it was 100 pieces. And now generate collection. So now let's do exactly the same. We move it to collection. We run yarn prepare. Everything is correctly set. The files are correct. Okay. Now go to Pinata, upload, folder, and select the images folder. upload and name it the way you want. So me, it's Wawa Pirates images. Okay, so now here we have our file on IPFS. We can watch it. It's hosted correctly. So now what we will need to do is to copy that CID. And what we will need to do if we open metadata is to replace all the images with IPFS and replace IPFS URI with the new one. So we won't do it manually. So I prepared a script for it. So go to your root folder, in tools, new file, metadatas update.sh. What it does is inside the folder collection and metadata, it will search for IPFS URI and replace it with your CID here. Let's copy ours. So it's here. Don't forget this or you won't point to the correct one. We have a simple shell function that will replace it in all files. And because it generated a backup file and I don't want and need it, I remove it just after. So in our package, we can add another script. Let's name it IPFS. And it would just call our script. So metadatas update.sh. Okay, save and yarn IPFS. Permission denied. So we need to put the right on metadata's update. So chmod. I will put all rights. Yep, chmod. Okay, now I execute it again. It said it worked correctly. So let's check our file. And yes, here the path is correct. If I copy it and open it, you will need IPFS extension so it works. I will put the link in the description, but here you can see that it's pointing to my file, which is correct. So now our metadata files are correct. We can upload it. So go back to Pinata, upload folder. Now let's go back to metadata and select this folder. Let's name it Wawa Pirates metadatas and upload. So now our files are on IPFS. So we have the CID and we can create our Solidity contract to mint our NFTs. NFT collection, Solidity contract. We want our NFTs to respect ERC-721 standards and to be available on OpenSea and other marketplaces. To write our contract, we will use remix.ethereum.org. But you have multiple options you can use. You can write it in Visual Studio Code and use Truffle to deploy it. But to make it easier, I'm doing it directly in the browser. If you want to deploy it with Truffle, I have a tutorial covering it. So let's create a new workspace, Wawa Pirates. Okay, we don't need the contract here, so we will delete everything. And we will create a new one. Let's name it nft.sol. We won't code everything together as I will create dedicated video to Solidity, but I will present the one we will be using. Okay, so first thing, it comes from a contract from Hashlib tutorials. I modified it just a little bit to make it lightweight and easier to understand. And we will see what it does. It imports OpenZeppelin contract, which contains the default method for ERC-721 functionalities. So what do we have? We have a base URI, which will be the address of our IPFS metadata files. We have the base extension. So for us, it's JSON. We have the cost, which is in Ether, the minting cost, if people want to mint, but we won't do it. Max supply, so finally it's 50 because we have only 50 images. Max mint amount, it's the number per session you will mint, so we will keep 20. So when our contract is deployed, it will automatically mint 20 NFTs. So, okay, maybe we will put 10 for a demonstration purpose. Here we have the method for base URI. We have the minting function, which is looking at as if we have Ether provided before doing it, and then it will mint. There are useful methods to update the cost once it's deployed, but we won't use it. And there is this useful function which is withdraw to get money back when you sell NFTs, to get them from the contract to you. So, okay, let's deploy it. So save the file. It will automatically load all the dependencies here. Click here. You will see no issues with the contract. Compile it. Once it's done, you can go here. It's okay, but I want to use my wallet. So I use injected provider MetaMask. And you need on MetaMask here to be in networks on Goerli test network, which is the one OpenSea use. So we will be able to test it on OpenSea before deploying the real one. How do you get Ethereum on Goerli? It's free. You don't have to put money for the testnet. I will put 2 links in the description, which led me to have more than 1 Goerli Ether. So once you are on the correct one, you can see on your account you have Ether, the correct amount. So yes, we are on the good chain. Before pressing deploy, we need to add some parameters to the contract. So the name of our collection, so it's Wawa Pirates. The symbol, so I will use WP, it's not WordPress, it's Wawa Pirates, and init base URI. And to get it, go to Pinata, copy the CID from the metadata, not the images, but the metadata, because it's the metadata that point to the image. Right here, IPFS, // paste the CID, and /, don't forget the trading /. Now you can hit transact. So I'm using a ledger, so I need to validate the transaction and hit confirm. So now I have review transaction. Okay, so I triggered it 2 times, so don't be afraid about this one. So now the contract is deployed. And we have all the available thing to interact with our contract. So we have approve, mint, renounce, safe transfer. We have a lot of useful thing. If you made a mistake about the base URI, you can update it. You can update the cost. You can withdraw what is on the contract. So if people mint NFTs, you can withdraw the amount on the contract. So we can call base URI to see what is the default URI. Now we can go to testnet.opensea.io, connect with your wallet, the same wallet you used, and now you should be able to see your collection. So you can see there are existing ones which were with errors. We have currently 10 pirates, but there is an issue on our collection because we can't see the attributes. So let's see what is happening. If we go to a JSON, okay, I made a mistake. I double wrapped the attributes. So it's not a big deal, but we will have to regenerate our collection. So let's do it another time. But before it, let's correct our script. So it's in experience, attributes. It's already an array that will return map. So let's fix it. Now let's generate our collection again. So let's remove it. Okay, so yarn prepare. It will clean everything. We can see that we have identical items. So I will wait again before doing the screenshot. And let's generate our final, I hope, collection. Let's delete our pinned item on Pinata. It was not a good idea to move out. So this is another downside. We have keep the browser open or it will take the same screenshot. So it seems good. Nice. Let's do the whole process again. But this time we will publish it to Polygon, to the real blockchain. So images. Okay. Now we have the new CID, so replace it here, save and yarn IPFS. Look at our metadata. So the attributes are correct, the image is correct. We can upload it to Pinata, Wawa Pirates metadatas. Okay, so now we have the CID of the metadata. Let's go back to Remix. What we will need to do, because we're happy with our contract, we won't need to compile it again. We'll need to deploy it again. So we'll switch in MetaMask into Polygon mainnet. So here you can see I have 50.9 Matic. On Polygon, when you see Ether, it means Matic, so don't worry. The cost here is 0.05 Matic, and same for here. So we will keep the same name, the same symbol, but we need to rewrite the init base URL, IPFS // CID from metadata and /. So let's verify I'm in the correct one. CQ is the metadata, so it's okay. Let's hit transact. Okay, I adjusted the gas, so I'm sure it will deploy this time. Review transaction, accept. And this time it worked. So we have the gas paid and we have everything here. So now let's go to Polygon scan and we see our transaction. We had the minting of 10 items and they have been transferred to me. Now let's go to OpenSea, but don't go to the testnet, just go to OpenSea directly. Now it asks me with which account I want to connect to. So I will select the ledger one, accept and sign. Sign the message on my ledger. And here you can see my collection is here. I have all my NFTs. And this time there's not the mistake. You have the property, so you have background, you see 13% of them have the C, etc, etc. Let's mint the other ones. So let's go back to our contract, go to deployed contract, go to mint. I will put my account. So here it is. And I will mint the maximum, so 20. Confirm. I accept it. So it's minting my NFT. It says it's been done. If I go to total supply, I can see there are 30 minted now. If I reload my account, I can see now I have 30 pirates. Look, is Luffy as rare as it should be? Pose. Luffy 17%. Okay, cool. Let's mint the 20 last ones. Again, to prevent to be blocked, I will edit the fees. I approve it. So now if we look at the total supply, we have 50 this time. So we have all our items minted and they should soon appear on my account, the 50 ones. Okay, I see all of them here. So what I will do is, as they know I am the owner of Wawa Pirates, I can add a cover and an image, so I will do it soon. And for the sake of this video, I will give maybe 5, maybe 10 NFTs to the one who wants to have them. And I will put them on sale so you can buy the other ones. I think I will keep one and try to use it on Twitter. Thanks a lot for watching. I hope you enjoyed this tutorial. I also hope you will buy a lot of Wawa Pirates because it is my first NFT collection. You can watch other 3D tutorial I made on this channel. It's a React Fiber playlist. And a month ago I also made a DApp tutorial, so it might be useful for you to go deeper in Solidity and if you want to go further and make a DApp. I think I will soon make another tutorial with a platform, a DApp, where you will be able to mint the NFT and you will purchase it and you won't know yet what you have, and once you mint it, you have a unique NFT. By the way, if you're looking to build a 2D collection, I highly recommend you Hashlip's videos, which cover what I did but with 2D images files instead of a 3D model, and he explained very well, so it might help you go deeper. If you enjoyed this video, please hit the like button, it really helps the channel grow on YouTube, and to be notified when new videos are released, please hit the subscribe button. Thanks a lot, bye bye.